Hi, in this tutorial we're just going to look at strong acids, and we're going to have a look at calculating the pH for that strong acid. So what do I mean by a strong acid? Okay, let's just draw that. Say we've got nitric acid, and that's in water, so I'll put AQ, and that is in equilibrium in water, so it can exist as this, and it can exist as its dissociation products, H plus the nitrate ion. Just about fit that on. Okay. So a strong acid, really, if I choose a different colour pen here, a strong acid is really driving the equilibrium over to this side. It likes to exist in water, more or less like these ions. There's not much of that around. Now let's compare that. Okay, let's compare that to a weak acid. A weak acid would be something like acetic acid. So we've got acetic acid. I'll just draw that, which is vinegar or ethanoic acid. Okay, so this is acetic acid, and that's in equilibrium too. Just the same process. Put AQ, and the anions from that are this and the proton. Now remember, the acidity of a compound is actually the concentration, the pH, sorry, is the concentration of the H plus ion. Okay, so that's what we're interested in. For a weak acid, it's kind of different because it's not all the amount of acid you add doesn't always generate you an equal number of protons. But in a strong acid, you can assume that it's gone all the way over to the dissociated form. So really the concentration of the acid here that you add, so whatever you add should, in theory, totally dissociate to give you H+. So let's just get rid of the weak acid for now. Let's try that out. Oops. Get rid of some of them. What have we got left? Right. I just tidy this up. So that's the idea. Strong acid has strong dissociation, so you get, basically you can say, and you might see this actually in your textbooks written like this, so the concentration of HA, that's our acid, and this is the negative ion, is pretty much equal to the concentration of H+, and that is for strong acids. Okay. Only for strong acids. So let's have a look at trying to calculate that. So if you remember, I'll just get rid of this. I'll leave this up at the side. If you remember, for calculating the pH, what we use this equation: pH equals minus the negative log. This is log at base 10. So sometimes you can have a 10 there, but we'll leave that for now. Base 10, the concentration of protons in solution, and that's concentration is usually in moles per decimeter cubed. Okay, so decimeter cubed, if you remember before, is the same as a litre, or 1,000 centimeters cubed. Okay. So we've got pH equals minus log of the concentration of that. So all we need to do now is, if we've got a pH value, we can work out what H plus is. If we know the concentration of the acid that we started with, we should be able to predict what the pH will be, providing we make the solution up as to the right concentration and things like that. Okay, but we assume we do that right. So the wet chemistry side should be done properly, as well as the calculation. So let's have a look at some figures. Let's have a look at, so say we do our, we don't know what the concentration is. Somebody's just added nitric acid to a solution. We know the volume, and it turns out to be a litre, which is quite convenient for us. But we have the value for the pH, and the pH comes out to be something like 2. Let's make it a bit more interesting. 2.2. Okay, so the pH is 2.2. So in order to calculate the concentration of H+, we'll have to rearrange this equation a little bit, and let's do that I'll do that in green so you can see it. So rearranging that needs to go to the power of 10. Okay, so if we rearrange this equation now, all we need to do is basically say the concentration of H plus equals 10, remember we've got the minus sign there, to the minus whatever this was, the pH, so we could write pH there. Let's write pH for now, and then we'll do it at another step. So minus whatever the pH value was, so it's 10 to the minus 2.2 in this case. Okay. Now what I'm going to do, I'm just going to get my calculator up. Not that I can do this in my head, just to try and show you how to move around the calculator, because that might be interesting too. So this is my calculator on my computer. Okay, so you'll have a different calculator, but this is a scientific calculator anyway. If I want to raise something 10 to the minus 2.2, you probably don't have that on your calculator at first glance. But you can see there's a log 10. That's important because we're going to use that for calculating pH soon anyway. So what I've got to do in order to calculate this is first of all put the value in, 2.2. Then I've got to negate it. I don't use this button, I'll use something like this. Have a look on the calculator for a plus minus button. And that means it's negative, got a negative value now. And then what I've got to do, this base 10 logarithmic value should have a complement, if you will. So it's just the same as this, let's move that out of the way. Just the same as this equation, you can raise it to the power of 10 if you take the logs. So this is my shift button, sometimes called an inverse button. Actually on there it's called an inverse button. So if you press that on your calculator, and then you hit that, you can see it's 10 to the power of now. So whatever value I've put in here, it should be 10 to the power of that. So if I press that, that should now give me a value for a pH of 2.2, pH of 2.2. Remember the pH wasn't minus 2.2, I've put that minus in because that came from here. That's very important too, because you've got a really strong acid which is got a minus pH, and that's going to be 10 to the power of a plus value. So our value there is 0. I'll just move that down a little bit, 0.0063. So that's the same as saying 6.3 times 10 to the minus 3 there. So I've moved that dot 1, 2, 3 values along. Okay, so just move my calculator out of the way now. So I'll write that value in. So it was, just get my brush, so that equals 6.3 times 10 to the minus 3 moles per decimeter cubed. Okay, so we've worked out, based on the pH, the concentration of H plus in our solution. So that's very useful. If you've got the right volume, remember that's per litre, so you've got to make sure you've got the right volume and stuff. And so we can put whatever volume you want in there, so long as you can work it back, because pH will come out a different value otherwise. Okay, so that's working from the known pH. If we didn't have the pH of 2.2, but we knew the concentration of H plus, well, that's pretty straightforward, because that's just going to be put into this value. So why don't we have a go at that actually? Well, just to end the tutorial, just get this out of the way. We know the value of H plus is, say it's, I'll get my brush, so the concentration of our acid that we start with, concentration of HNO3 equals concentration of H plus that we'll get, that's the H, sorry. And let's say that is something like 0.013, I'm just making this up as I'm going along, moles per decimeter cubed. Okay, so I'll show you how to do it on a calculator again. We've got this value, so from that value all we've got to do is take the negative log of that value. So pH, let's just do that in a different colour, because I know it can get a bit untidy. So pH equals minus, we've got the log of our new value there of, I'll put that in brackets, 0.013 moles per decimeter cubed. Okay, so all we've got to do is plug those values in. So let's do the first one. Let's get the calculator back up and just move that across. So I'll just move that up a little bit. Cancel that. So this time we need to put this value in. So it's 0.013. We're going to take the log of that, and then we need to negate it because we've got this minus value there, so take the negative sign of that. So we just hit that button again, okay? And so our pH will be 1.89, okay, because of the 6 there. So I'll just go to 1.89 for now. I could go to 1.9 if I wanted to. It depends on the accuracy of what we're doing there. And we save the accuracy and precisions of numbers for another tutorial. Actually, it's quite important, so we'll do that in another tutorial. So let's say 1.89. So the pH for this solution here turns out to be 1.89. Okay, so that's the value we get for this strange number which I just made up in my head. So hopefully that's introduced you to how to calculate the pH and concentration of H+ for strong acids. Remember, this was for strong acids. Next time we'll have a look at weak acids. So bye for now.